Okay, question number 3. State whether the following equations are equal or not, and we need to justify our answer. We need to do this using the structure of the equations. We are not trying to solve these equations. We want to know whether or not they would have the same answer, but we are not interested in what that answer is. So let's see. When I look at this equation over here on the left and I compare it to the equation over here on the right, I see this 3x and 6x. I see 9x. I see 2x. I'm curious. It doesn't look like quite the same order to me, but what if I multiplied everything by 3? And I decided on 3 because I see 3 and 4 and 2 and 8. And here I see 9 and 12 and 6 and 24. So I know that all the numbers over there on the right are multiples of the ones on the left. If I just take and multiply everybody over here by 3, it might help me see this a little bit easier. So when I do that, I get 9x minus 8, or sorry, not 8, minus 12. 9x minus 12 equals 6x plus 24. So I multiplied everything through by 3. That is the multiplication property of equality. So there's my justification for that step. If you remember our properties, these are the rules of algebra. You guys have used them before. Okay. So when I look at this now, my numbers and my variables seem to be matching up. 9x and 9x. I see negative 12 with the 9x, negative 12 with the 9x. Cool. I see 6x plus 24, and over here I see 6x plus 24. So I want to make the one on the left look identical to the one on the right. So I'm going to try to get it in the exact same order. To do that, I'm going to take this 6x plus 24, and I'm going to flip it. Just switch sides of the equal sign and move the 9x minus 12 to the other side also. So 6x plus 24 equals 9x minus 12. When I switch sides like that, that is the symmetric property, or you could call it the reflexive property. Symmetric, it's the same on both sides. That's why I can do that. That's what symmetry means. So I'm just writing down my properties that I'm using so that I can justify my answer. All right, let's see. 6x plus 24 is exactly the same as 6x plus 24. And then over here, it's negative 12 plus 9x. And here it's a positive 9x and minus 12. So I can flip those two around as long as I take the signs with them. The 9x is a positive, and the 12 has a minus sign in front of it. So 6x plus 24, I'm going to leave just like that, because that already matches my other equation. And then here, I'm going to move the minus 12 up to the front here, and 9x is positive, so plus 9x. And what I just used there is called the commutative property of addition. And what the commutative property of addition says I can do is that I can take two things and make them change places. So commutative property of addition is basically saying that 5 plus 7 is equal to the same thing as 7 plus 5. That's what my commutative property of addition says. That word commutative, I don't know if you've ever heard the word commute before, but when people talk about having to travel back and forth for work or for school, a commute is meaning that you need to travel or you need to change your location. And so that's why they use that word there. So looking at this now, I have 6x plus 24, 6x plus 24, negative 12 plus 9x. On the other side, negative 12 plus 9x matches both sides. So these two equations are equal. So these two equations would have the same solution. These two equations have the same outcome. They are interchangeable with each other.